Hi friends, welcome to Decluttered. In this episode, let's look at this amazing question on application of derivatives that I came across while I was helping some students solve application of derivatives. The question reads, from a point P0 on the curve y is equal to x cube, a tangent is drawn which cuts the curve again at P1. From P1, another tangent is drawn which cuts the curve again at P2, and from P2 we are drawing a third tangent which cuts the curve at P3. The question states, find the area of the triangle P1, P2, P3 is to area of the triangle P0, P1, P2. By the looks of it, the question sounds very challenging, but if you have confidence in your ability and conceptual clarity, especially around theory of equations, this question is a sitter of a question. Let's first understand what's happening in the question. So we have the curve y is equal to x cube. From the point P0, I will draw a tangent that cuts the curve at P1. From P1, I will again draw another tangent that is going to cut the curve at P2, and then another tangent. So this keeps happening. We essentially have to first find the coordinates P0, P1, P2, P3, and then using matrices or determinants we can find the ratio of the areas. Let's understand how to do this question. Let the point P0 be represented as h, h cube. I am taking it in parametric form. Now the curve is y is equal to x cube. So if I find the derivative, it is 3x square, and the derivative at h cube, y dash at P0 is 3h square. So the equation of the tangent is y minus h cube, the point P0, by x minus h is equal to 3h square, and if I cross multiply, I will get 3h square x minus 3h cube plus h cube is equal to y, or y minus 3h square x plus 2h cube is 0. So this is the equation of the tangent at P0. Since this tangent cuts the curve again at P1, what I'm going to do is this point, the y of this point P1 can be replaced. Let P1's y be given by k cubed. So the x is k for this, right? So I can say that since y is equal to x cubed minus 3h square x plus 2h cubed is equal to 0. As you can see, this is a cubic equation. A cubic equation has 3 roots. How did I get this cubic equation? By substituting the tangent in the curve, which means there should be 3 roots. And where are 3 roots? We have learned that if a line is a tangent to a curve, it has the same solution, hence 2 solutions. So this will have 3 solutions. The first solution of this is h. The second solution of this is also h because this is a tangent. And the third solution, when we find, we will get this equal to k. Let's solve this. X cube minus 3h, x cube minus 3h square x plus 2h cubed is equal to 0. Now x minus h the whole square into x minus x1 is equal to x cube minus 3h square x plus 2h cube. Since I have already solved this, I know that x1 is minus 2h, which will give y1 is minus 8h cubed. And if you see the pattern, P0 is x0 is h, y0 is h cubed, P1 is this, by extension P2 is going to be x2 is 4h, y2 is 64h cubed, and P3 is going to be x3 is minus 8h, y3 is minus 512 h cubed. We just need the area, so half of minus 2h minus 8h cubed 1, 4h 64h cubed 1 minus 8h minus 512h cubed 1 divided by half of h cubed 1 minus 2h minus 8h cubed 1 4h 64h cubed 1. Half and half will cancel. From this, if I take minus 2 common, and from here if I take minus 8 common, this will become h cubed a minus 8h cubed and 64h minus 2h and 4h. These two determinants will become the same, so they will cancel and the answer is 16. And that's the way we solve this. The concept that I wanted to convey to you is that if a line is a tangent, then the roots are the same. And this concept is also used in conic sections when we try to derive the condition of why a certain line is a tangent to a circle, a parabola, or an ellipse, or you name it, right? Please have this concept at the back of your head, because if by chance you forget the condition in the exam, it's easy for you to quickly derive it. I hope you like this video. If you did, please do like, share and subscribe.